Welcome to CSC channel, Competitive Science channel, chapter Motion, part 2. Last video, in the part 1, we have discussed about distance traveled and displacement. Today, we are discussing about continue of that part, that is uniform motion. Equal distance traveled by a body in equal interval of time is called uniform motion. The word uniform shows an equal distance. Example, we have taken time in the x-axis, distance you have taken in y-axis, distance measured in the meter, time is measured in the seconds. X-axis 1 centimeter is equal to 5 seconds, y-axis 1 centimeter is equal to 10 meter. Now, if an object travels in 5 seconds 10 meter, another 5 seconds, that means in the 10th second it is 20 meter, another 5 seconds, that means 15 seconds, it is 30 meter. When you coordinate these 3 points, it will become a straight line. Hence, uniform motion is always straight line. This is a competitive examination. In that they will ask a question, what type of graph we can be noticed in uniform motion. That is, in the uniform motion, the graph will be straight line. Now, non-uniform motion. Unequal distance travelled by a body in equal interval of time is called non-uniform motion. Example, in the graph, x-axis we have taken as a time which is measured in the seconds, y-axis we have taken the distance measured in the meter. As usual, x-axis 1 centimeter is equal to 5 seconds, in y-axis 1 centimeter is equal to 10 meter. 5 seconds, 10 seconds, 15 seconds, 20 seconds. Here it is 10 meter, 20 meter, 30 meter, 40 meter. Now, if an object travels 10 meter in 5 seconds, in another 5 seconds, if it is about 5 meter only, then it becomes like this. In another 5 seconds, if the object is 30 meter distance there, or in another of means 5 seconds, if it is 20 meter, then the graph is coordinated these points like this. Then this is called as curved line. So, non-uniform motion always shows and represents curved line. Move, speed and velocity. First, speed. Speed is a scalar quantity which shows only magnitude. Coming to the definition, total distance travelled by a body. Travelled by a body in unit time is called speed. Example, many times we are talking vehicles. It is 60 kilometer distance, 50 kilometer distance travelled per hour, or 20 meter per second. We are telling the distance in the speed, but we cannot say, or we are not mentioning the direction. Hence, only magnitude you are showing, so it is called as a scalar quantity. Coming to the formula, speed is equal to distance travelled divided by time taken. So the formula becomes S by T, where the distance symbol is S, time taken symbol is T, and unit of speed is meter per second. SI unit is meter per second, but sometimes in the larger scale we are using kilometer per hour, but SI unit is meter per second. Coming to velocity, velocity is total displacement of a body in unit time. That means in a given time, how much displacement of an object occurs is called velocity. Velocity is a vector quantity. It shows magnitude and direction. Example, the 60 kilometer vehicle moves 60 kilometer per hour towards Bangalore, or it is returning from the Bangalore with a speed of 50 kilometer per hour. That is called as velocity. Speed and velocity both same in the sense, but we are mentioning an arrow mark on that shows it is a vector quantity. So displacement of an object divided by time taken. The same V arrow mark S by T, which is the same SI unit. SI unit is meter per second. Here, the speed is a scalar quantity which has only magnitude, but velocity has both magnitude and direction, hence it is called as vector quantity. Coming to the problems of speed. So some easy problems now we will discuss. Later a difficult problems will come. So this is 6th and 8th standard problems it will be there. So next we can move for higher problems also on the speed. The speed of light in vacuum is 3 lakhs kilometer per second and it takes 8.3 minutes to reach the earth. Calculate the distance of sun and the earth. Example, this is the sun. It takes 8.3 minutes to reach the earth and the speed is 3 lakhs kilometer per second. Here the unit is per second, here the minute is there. So the time we have to calculate in seconds. So 8.3 minutes is converted into seconds. 6 3s are 18, 8 6 are 48 plus 1 49.0. So 498 seconds will be there. Now speed formula, distance divided by time taken. Now distance we want to calculate. So when you cross multiply the speed into time, so distance is equal to speed 3 lakhs kilometer. So 3 lakhs kilometer is 3 into 10 power 5 kilometer. When you convert into meter, it is 3 into 10 power 8 meter. 8 meter into time 498 seconds. So distance is equal to, when you calculated there, 1494 into 10 to the power 8 meter per second. Or we got approximately 150 million kilometer. Okay, one more problem on this in the speed problem. An artificial satellite is moving in a circular orbit of radius 42,250 kilometer. Calculate its speed if it takes 24 hours to revolve around the earth. Here the problem, the circular of radius is given, that is 42,250 kilometer is there. So it takes time 24 hours. So there is no calculation for time and distance because you can calculate in kilometer per hour only. Now the formula, speed is equal to distance divided by time taken. Here the distance in the terms of circle, it is a circle, so the total distance for the circle is 2 pi r. Now 2 into pi, 22 by 7 into R means 42,250, or 22 by 7 we calculated is 3.14. The answer is 265571.43 kilometer. This is an approximate value. Then the speed is equal to 265571.4 divided by 24 hour. This is kilometer. The answer you can be keep in kilometer per hour only. The answer 11065.48 kilometer per hour. This is called speed. Now we come to average speed and average velocity. Now actually in higher classes the questions will be arises only in average speed and average velocity, not of speed and velocity. Now come to the definition of that. Average speed means total distance traveled by a body in total time taken. That is, average speed is equal to total distance divided by total time taken. The SI unit is same, meter per second. Similarly, an average velocity there, it is total displacement by a body in total time taken. That means average velocity, here the speed and velocity is same, but here an arrow mark we are writing that shows it has both magnitude and direction. Here total displacement means change of position. Total displacement of an object, difference between initial position and final position divided by total time taken. So here also SI unit is meter per second. It seems to be a simple, but the problems will be little complicated. Now next we are going to solve the problems of average speed and average velocity. Now we can move for the problem solving on average speed and average velocity. As I told, first we will go for a simple problems, then we will go to complication problems on average speed and average velocity. Usha swims in a 90-meter long pool, covers 180 meter in 1 minute. Calculate total average speed and average velocity. For that, we have to write a pool of Usha swims in a 90-meter pool and covers 180, means she again come back. So 90 meter plus 90 meter is 1 meter, 180 meter, and covers in the time of the 1 minute. 1 minute means 60 seconds. Now they are asking average speed. Average speed means you know already, total distance divided by total time taken. So here it moves 90 plus 90, 180 meter she covers. So divided by 60 seconds. So here 90 plus 90, 180 divided by 60, that is 3 meter per second is an average speed. Coming to average velocity, total displacement divided by total time taken. Now, total displacement means initial position A, she moves 180 meter. So, initial position A and final position is A. So, total displacement is 0 divided by Total time taken 60. Any number divides the 0 is 0 only. So hence it is 0 meter per second velocity. Now we'll move a little difficult questions in average speed and average velocity in PU. A particle moving in a straight line covers half the distance with the speed of 3 meter per second. The other half of the distance is covered in 2 equal time intervals with the speeds of 4.5 meter per second and 7.5 meter per second. The average speed of the particle during the motion is, option they will give, 4 meter per second, 5 meter per second, 5.5 meter per second, 4.8 meter. The particles here to here moves means we divided here s by 2 of distance. It is the time taken is 3, means speed is 3 meter per second. So we consider this timing as a t1, and here in the t2 here in this side, the another half of the distance covered by different speeds, 4 meter per second, 7.5 meter per second. We consider as this is S1 and another is S1. This together we call as T2. Then the average speed is equal to total distance, means S is the total distance divided by total time taken. This is one time, this is another time. Here another time 2 will be there, so we call T1 plus 2T2 timings there. And here the T1 we want to calculate. Speed is equal to distance divided by time taken. Time is equal to, so distance divided by speed there. So T1 is equal to S by 2 divided by 3. That leaves to S by 6. So T1 becomes S by 6. Then for the T2, here S1 plus S2 together are there. So 4.5 plus 7.5. 12 T2 will be there. So this is S by 2. S by 2 is equal to 12 T2. T2 is equal to S by 24. S by 24. Now you apply here S by T1 plus 2 T2. S by T1 S by 6 plus 2 T2 is there. So 2 into S by 24. Now S LCM get taken 6 and 24. 24. So 4s plus 2s, then it goes to outside. So 24s divided by 6s, sx cancel, 6 4s are. So 4 meter per second is an overview there. A fan rotates at 100 revolution per minute. Find its angular velocity and linear velocity if tips of the blade of the fan is 0.20 meter away from the axis of the rotation. Here angular velocity means when an object revolves around the particular the circle, it moves like this. This is called angular velocity. Linear velocity means straight line velocity. Now the formula for angular velocity, symbol W is equal to 2 pi and frequency. 2 pi into frequency. To calculate the frequency, it is given 100 rotation per minute. So 100 divided by 60, 5 by 3 frequency. 5 by 3 the frequency. 2 pi, 22 by 7 or 3.14. 2 into 3.14 into 5 by 3, that gives to 10.46 meter per second. This is an average velocity, angular velocity of that. Now coming to linear velocity means straight line velocity. The difference between or the relation between angular velocity and linear velocity is angular velocity into radius. Angular velocity into the radius of the blade. So Angular velocity is 10.46 into 0.20 meter. So 2.080 meter per second is the linear velocity. Coming to the types of motion on the basis of dimensions. On the basis of dimensions, there are three types of motions are there on the basis of dimensions. We call single dimensions. Means if 3 points, coordinate points are there, then the motion of object can represent only or n of one particle or coordinate only one point, then it is called as monodimension or a single dimension. Example, linear motion. Coming to the second type, double dimensions. Dimension means two dimensionals. There, if the 2 points coordinate, any 2 points among the 3 coordinates, then the motion is represented in the form of circle. Example, circular motion. Third one, three-dimensional motion. Example, if all 3 points together, if they cross in a motion, all 3 points are represented. That is called three-dimensional. Example, flying of birds. Flying of birds, movement of aeroplane, and even kites flying in air. Movement of kites also shows three-dimensional motion. So motion can be represented in the three types on the basis of dimension. Single dimension, double dimension, three dimension. Single dimension or a monodimension is a linear motion. Double dimension is a circular motion. Three-dimensional motion, example, flying of birds, flying of kites in the air, movement of aeroplane. Next, we are going to discuss about acceleration and its problems in the part 3. Thanking you for viewing my video of motion part 2. If you like, please subscribe the video for the next